you go. So we're going to start out today, and forgot to bring the eye clicker thing. So on the way out, I'm going to have everybody show up today, kind of write their name on a piece of paper, and I'll kind of treat that as though you get your eye clicker score for the day. Getting this to 10 out of 10. So the paper, I had the HDMI cable. Was talking about kind of racial discrimination in hiring practices, right? So we talked a little bit about discrimination, kind of the implications for wages. But you can also imagine when we had this discrimination, it was decreasing that demand curve, which would also not just only push the wage down, but would also push down the equilibrium quantity, right? So if we do have discrimination going on, we would expect lower wages, but also just fewer of whatever groups being discriminated against. So this paper is a little bit older now. I keep thinking, I mean, I'd love to see it with some of the newer data. So 2016, not too long ago. And they really wanted to dive into this issue. So I'm going to break this paper down a lot more than we usually do. I keep scrolling down. They got a lot of prior stuff. Oh, never mind. I have this old version of the paper. That's why. So actually, all of our tables are kind of down here at the bottom. I've actually got some of this already pulled up in the slides. So we'll go right here. Whoops. So during their time period, I think their data only went to 2013. And 2003 was kind of the year that this Rooney Rule began, which I believe the requirements of it is something like if you're interviewing for a coaching position, you're required to at least interview one minority candidate. And, you know, did it have an effect? We'll kind of see as we go through the paper. But at least just looking at the numbers, we saw more, you know, the number of minority coaches more than double, right? But if we still look at kind of the overall racial composition, right, 72% of head coaches during this time frame were white, 27 were black, right? And you look at the percentage of you know, the players, it's much more kind of even, right? So that would kind of suggest that maybe white coaches are kind of overrepresented, black coaches or minority coaches are a little underrepresented. But that's, you know, we haven't controlled for anything here. So there's a couple different types of discrimination that we can think about here. So one is going to be just within job. This is a traditional kind of discrimination we're thinking about, where two individuals performing the exact same level, right? And I'm more likely to choose the non-minority or the white instead of the minority candidate, right? That's just two people, exact same quality, but one of them is getting hired or one is not getting hired because they're a group that's being discriminated against. Right? Allocative discrimination is the idea that it's starting more downstream, right? So if initial hiring, right, for minorities is for these lower wage positions, it makes them less likely to be able to move up the ranks. So this is kind of the idea the paper will dive into, which is, well, if white coaches are given more opportunities as, say, offensive or defensive coordinators, and those positions are more likely to get promoted to head coach, then if I'm seeing more black coaches represented in things like, you know, running backs coach, quarterback coach, kind of the lower coaching positions, which are less likely to be promoted to head coach, then that discrimination early on is going to make it look like there's discrimination going on at the hiring decisions for head coaches. But it's not there's discrimination going on for hiring head coaches. That discrimination actually came way back when I was hiring my offensive, defensive coordinators at other positions. Okay. So we're going to try to determine, kind of break this down, or the paper's going to try to break this down. So you kind of think about, right, there's just a general hierarchy we have. Usually it's kind of like you've got your head coach, your offensive, defensive coordinator. It's kind of the next level. They're more likely to get promoted to head coach. It's less likely that then one of the positional coaches skips the coordinator positions altogether and gets to become head coach, right? So what's interesting is if we look at during this time period, the racial composition of these different coaches, first of all, right, this is like the percent of all coaches that were in these categories at like 3%. So over this time period, we actually had kind of the first coaching job, right? So this isn't necessarily of all the coaches, but your first coaching job was a head coach. So this is probably someone who like was coming from that, who would be an example. Urban Meyer, right? Goes right from college, skips the entire process. there's only like a couple white coaches who that happened for, no black coaches. Same kind of thing for head defensive offensive coordinator. We only had a couple white coaches that being their first job, no black coaches was at their first job. We then kind of transition, you can see there's a pretty big disparity in terms of quarterback coaches. And then a lot of these other positional coaching positions, or all these other coaching positions, some of them we even have more black coaches being that's their first job. So right away, if being an offensive or defensive coordinator makes it more likely or increases the probability of being hired as a head coach, this is going to cause some allocated discrimination, right? And it's not, to say it's discrimination on its face, we haven't controlled for a lot of other factors like the candidates, prior coaching experience, things like that yet, but this is just kind of our first look, right? And then they estimated with a bunch of data, they said, okay, look, actually, I'll show you what they did here. So I got some new markers here, so hopefully you should put it in. So really what we're thinking about doing there is, how likely is it that I get hired as a head coach, right? This is just going to be kind of a 1-0 variable. So we're going to get a little bit of difference in interpretation today because we're dealing with a dependent variable or a Y variable. That's 1-0, right? What we're then going to have over here on the other side is indicators for offensive coordinator, defensive coordinator, all the other positions, right? And these are all going to be kind of 1-0 variables as well. So the way that we can kind of interpret these coefficients would be beta 1 is the expected increase in our Y variable. But how is our Y variable measured? Well, if we have a 1-0 variable, right, is our dependent variable, we kind of think about it, we're moving from 0 to 1. That's a change in the probability that that variable is a 1. So beta 1 will be the expected increase in the probability of being hired as a head coach from a 1-unit change in our X variable. What's a 1-unit change here? Going from that 0 to 1 would mean they're an offensive coordinator, right? So if the coach I'm looking at, their prior kind of work experience was that they were currently an offensive coordinator, like going from that 0 to the 1 group, it would increase the probability of being hired as a head coach by whatever that coefficient is. And then for the defensive coordinator, it would be, there's the expected increase in the probability of being hired as a head coach if I'm a defensive coordinator. Expected probability if I'm a running backs coach, et cetera, right? So they ran that regression, obtained those coefficients, and really that's all they're doing is kind of plotting these here. So you can kind of see, and then they use some bars to make it a little bit nicer, right? The offensive defensive coordinators, the probability I get hired as a head coach is much, much higher than for any of these kind of positional coaching, or these, it's like the coaching positions of running back, quarterback coach. I think it's kind of interesting in terms of some of the what could help us with the allocative discrimination is if we look at kind of secondary coaches, they have the third highest probability of being hired as a head coach. And if we go back, that coaching position is predominantly black coaches. So that's going to help alleviate some of that allocative discrimination that we thought might be going on. Okay. We'll keep going. And then this is percentage of coaches who played during college. It's pretty similar across kind of the two races. So here was kind of their first regression. Okay? And they kind of break it down. Each one of these columns, they do something a little bit different. Okay? So here, they're only going to include offensive and defensive coordinators. Okay? They're then going to run this regression of whether or not they're hired as a head coach, similar like we just had written out, except now they're going to include, call this on B5 or whatever. Oh, I forget how they did this. They probably did, I think it was, they defined the variable as white. So 1 if the individual was white, 0 if not. So beta 5 here would tell us the expected increase in the probability of being hired as a head coach if the candidate is white compared to black, right? Going from that 0 to that 1 group. So if there is discrimination going on, what should the sign of that coefficient be? Minority candidates are being discriminated against. then being a white coach should increase or decrease the probability. Yeah, should increase the probability if there's discrimination going on against minority candidates. If I find a negative value here, that would actually tell me what? That that white coaches are actually being discriminated against, right? If I find a 0, it's good, right? I mean, there's no discrimination going on, or something close to 0. So let's look and see what we found here. If I can get this thing out of the way. Don't want this up here. Whatever. It should let me drag this. There we go. I'm going to. Don't want this anywhere. Well, here we are. So here's that variable I'm interested in, whether or not the coach was white. My dependent variable here is, was I promoted to a head coach? Now, they only ran this for offensive and defensive coordinators and found that in the hiring practice for those coaches, that the white candidates actually have a much higher probability of being hired as a head coach. Okay? So that's troubling. They then kind of progress. Okay, well, before all they had was these year fixed effects. So I've mentioned fixed effects before. This is just including indicators that control for what year it is, right? That would help, adjust for inflation, things like that. What they didn't include, well, what was the first position of the coaching question, right? So we have a lot of these coaches who are offensive and defensive coordinators, but we also might want to know, well, what was their experience before that, right? What was their first kind of position they started coaching at? And then we didn't include any kind of what was their current position, so whether or not they were offensive or defensive coordinator. And so we then kind of progressed where they started including all these additional fixed effects up until this, fourth column, where we've included all this. So we're controlling for more factors, right? So this first column was kind of a naive regression. We weren't controlling for some of the previous experience of the coaches. We also weren't controlling for what their current kind of position was. Right? So we kind of progress to that fourth column. We now see that our estimate, while still positive, right? Once we've controlled for these other factors, we no longer can say that it's statistically different from 0. So at least it looks like here that being promoted to a head coach, right? There's no discrimination on once we control for these other factors. Now, what's a little bit more interesting, though, is if I control for all of these factors and I change my Y variable. So instead of being hired as a head coach, I'm going to get rid of these, fill these in with running back coach, quarterback, all the other positional coaches. And I'm going to say, I want to have this 1-0 variable, which is just, did they get hired as an offensive or defensive coordinator? Okay. So now these coefficients would be, here's the increase in the probability I get hired as an offensive or defensive coordinator if I'm a white candidate versus a non-white candidate. Holding constant, my current position, my first position in the league, and they had other things like age. We'll go back here. They showed some of the controls, right? So whether or not they had a bachelor's degree, the team's winning percentage that they were currently on, all these other kind of control variables as well, right? And so we're saying two candidates who are the same age, the team has the same winning percentage, same years of NFL coaching experience, so on and all the way down, right? But one of those candidates is white, the other is non-white. What's the change in that probability of being hired as a coordinator? And what we see there's a positive effect there. The discrimination isn't going on at the head coach hiring decision, or at least we don't have evidence of that from the data, but we do have evidence that there's some discrimination going on promoting positional coaches up to that coordinator position. So this would be something like we see, black coaches spending longer or a higher number of years, right, at these lower positional coaching positions and are less likely to be hired to the coordinator position. We then have the allocated discrimination going on because we know that the two positions that are most likely to be hired as a head coach are offensive and defensive coordinator. Is that making sense? Some questions on that idea? Let's see if I think I might have just copied this one table because that was the one I liked the most. But let's go. What was this one? That was the same idea. Let's go back to the paper here. So I think there's another table that they have. So yeah, I stole all this. We just looked at, we looked at table 5. Yeah, so that was the one I wanted to kind of focus on. What's kind of interesting though, I don't really understand why they didn't do, I mean, I guess it's a separate paper. But let's say I'm skeptical that the Rooney Rule is working, right? And that a lot of these teams are just doing lip service, kind of going through the motions. They're just, interviewing some minority candidate, but they have no intention to hire them anyways. Right? What's a regression I would run if I was kind of had I could do head coach, or I could even do the offensive defensive coordinator, since that's kind of where we saw the most discrimination going on. How could what would I want to do on the right-hand side to determine whether or not the Rooney Rule had an impact on coaching decisions? A little bit kind of like what we talked about last week. So one thing I could do is just say, okay, I'm going to put a 1-0 variable where it's just a 1 if the year in question or the observation came from the year in which the Rooney Rule had been instituted, right? Because they had some years prior to it, they had some years after. So that's going to tell me kind of what that impact was for any coach, right? Which, this might be 0 because we're not controlling for the race of the coach. They're going to have just if the Rooney Rules in effect that year, what was the change in the probability that anybody gets hired as an offensive defensive coordinator? What we'd probably be more interested in is when actually I would probably set it up like this. So non-white, right? And then I would include, we talked about this last class, if I think that there's differences in groups, so if I think that potentially the probability I get hired as an offensive defensive coordinator, if I'm non-white, that might have changed after the Rooney Rule was instituted. So if I ever think that there's a difference in 2 groups, here my groups are 2 different time periods, we said we could include an interaction term, right? If these are both 1-0 variables, the only way that this is 1 is if it was a year in which the Rooney Rule was in place and the candidate was non-white, right? So beta 3 here would tell us the change, right? Or the change in the probability of being hired as a coordinator if I'm non-white after the Rooney Rule is instituted, right? And my guess is, that problem, hopefully, that that's eliminating discrimination, it should be kind of a positive value, right? That being a non-white coach after the Rooney Rule was instituted hadn't increased my chances of getting an offensive defensive coordinator position. Or I could do it for head coaches as well. Any questions on that before I keep moving? Okay. So that is a little bit of discussion of discrimination. I was thinking of maybe going a little off script today, but I think we'll do at least a little bit of this, and then we'll maybe look at something that I think is kind of interesting. And also, I'm not sure you could find it anywhere else. So let's think about a scenario, and we'll talk a little bit more about probably NIL next week. Look for very similarly. But let's think about if instead of the current situation, we allowed there to be a free and open labor market for college athletics, right? So if colleges wanted to pay players, they could. It's not just that they can only give them a scholarship. And so if we just use the NFL and NBA as kind of our benchmark. So for the NFL, you think about 48% of overall revenue goes to kind of player salaries. So if we just use that percentage and say, okay, what's the revenue of the average revenue of an Division I basically football program? It's about 32 million. So if 58% of that went to the players, each player on average would make about $180,000. Now we know if this is a free and open labor market, not everybody's going to make 180. The punter probably, doesn't make as much as the quarterback, right? Thinking about the number of additional wins they would add, right? But if we were to pay every single player the same, this would be kind of our equilibrium wage, right? You can do a similar thought process for basketball. It ends up being a little bit higher, even though revenue is a lot less, just because there's fewer people on the team, right? So it's getting spread across a fewer number of players. So the other problem, if we allow colleges to pay players, we're thinking about, would there be one equilibrium wage? Well, it's definitely going to vary by sport, right? And that's because if we think about what we were doing before, if if we've got our labor market, and let's say I'm going to do football and do golf, right? So we have the same supply of labor, right? But remember, our demand curve for labor is based off of the marginal revenue per win times the number of additional wins added, right? Or this you can kind of think about for golf is like some measure of quality, right? Well, the additional revenue generated from a win in a Division I football program is a lot more than a Division I golf, I guess what we call it, golf match, right? So we know that something like this would exist. And then if we allowed it to be a free and open labor market, the wages we would see paid to college football players much greater than the wage paid to golf players. Right? Questions on this shouldn't be too bad. We're just thinking about, right, we have different revenue generating sports. So it's kind of interesting to think about is currently, well, I don't know if this is the case, but I'll use it as a hypothetical. So let's say here we've got the value of kind of tuition or these scholarships the players were previously been getting, right? So it's not that, maybe this new system, we're just allowing players to be paid, right? But they're no longer they're no longer awarding scholarships, right? Well, before, what was the kind of wage that the player was getting paid? It would be the value of that tuition remission, right? However much money they were saving, right, by being a student athlete, how much they didn't have to pay the tuition anymore. So it could be that for some sports, if you did switch to a model where it was a free and open labor market based off of demand, they actually would be getting a lower value, right? Now it wouldn't be in the tuition remission, it would be in actual money, right? So maybe, maybe some people have a preference for that, but it could be possible that for some of these smaller revenue generating sports, the current value of the tuition remission is greater than a wage they would be paid. Now my guess is for things like football and basketball, that tuition remission is going to be much lower than what most of the players in the equilibrium wage would be. Questions on that idea? Yeah.
Yeah, so is this supposed to represent like the individual player or the like organizations? Because like per capita, like a golf player might be making more money than a single football player.
So think about this so we're looking at, if we're comparing sports, in a way, what we're doing is really using kind of the average marginal wins coming from that labor and the average marginal revenue per win, right? I can break this down by school because I know I could have more demand because I have one for every single school, right? So your larger schools, higher demand curve, they're going to be able to pay a higher equilibrium wage, right? But yeah, I wouldn't think about it so much as this is the total amount of money given to the team. This is going to be how much each player would earn holding constant their quality, right? Because I know that there's also going to be, this is like, instead of football here, I could do like quarterback, I don't know, cornerback, right? I also have different demand curves coming from those positions as well. So I'm thinking more so about like holding constant the quality of the player, right? And so we're more so looking at like the average quality football player compared to the average quality golf player. Does that make sense? Yeah, we could, in practice, right? We could have like a million different demand curves and kind of identify all the equilibrium wages for every sport, for every quality of player. It's just that here I'm just kind of holding that constant. Any other questions before I keep moving here? All right. So I went through this a little bit, and if we spread the revenue out evenly, right? So the total revenue on average earned across every single athletic department is about 44 million. So instead of just paying football players or just paying basketball players from those revenue streams, let's assume I want to treat every student athlete the same. So I take the total amount of revenue earned by the entire athletic department, I have to give it out to every single student athlete, it actually kind of results in about $38,000 per student athlete, right? So on average, if I was to give out all these funds equally, right, I'm guessing for most schools, this is gonna be varying the tuition, right? Unless they're out-of-state students, I guess. Yeah, I was looking at the other day, I use out-of-state tuition is like, I think it was around 38,000. Like, I think the in-state's only like 12 or something like that. There's like a crazy disparity. Anyways, so if we did that for non-FBS or FCS schools, so these are like Division II, Division III schools, smaller universities, we'd still have student athletes earning about 6,000 a year. So here, the argument would be probably at some of these D2, D3 schools, if you're getting a tuition remission, you're probably better off than if they were just paying you a wage. But if you're in a Division I school, probably a little bit better off, like I said, unless you're an out-of-state student or going to Notre Dame or something like that. Right? Questions on this? A thought experiment. But there is a model that kind of already exists. So I mean, I kind of understand why the NCAA is resistant to it. It's probably not going to matter since we have outside kind of money paying players now with these NIL deals. But if the universities wanted to pay players, they really already have a system set up for it, which is the way that they pay grad students, right? So if you're, applying to a graduate school, a lot of the times they'll give you like an assistantship or a fellowship, right? As well as tuition remission, right? So the athletes would still be getting the same value of that tuition remission, but also getting paid on top of that, right? Now, those stipends of grad students aren't very, it's not like they're making, I think mine was like, I think it was like $18,000 I was living off of every year. So it's not, it's not a lot, right? But, right, it is something, and for these players, right, they're generating a lot more revenue than I generated as a grad school student. And so, you could probably see some pretty high equilibrium wages, like, it could vary across departments. That's how finance programs give a lot more money as a stipend than history programs, more often than not. In fact, a lot of history programs don't even have assistantship, right? And so it could vary across departments. You could also have it vary across athletic department, right? Across sport, right? So this model's really kind of already set up pretty nice for this. Why they don't adopt it, I'm not entirely sure. Because even if it was a moderate stipend, and you put a limit on it, at least you still allow some of these student athletes, to recoup some of the value they're bringing to these schools. So we'll draw this out again just to kind of highlight this fact because it's interesting. I'm I don't know, a bit of a libertarian, and I think that we should, allow. I don't like government intervention. So if we think about what's currently happening, and we'll think about like, I don't know, top quarterback at a D1 university, maybe even in the SEC. I labeled this because I was talking. Sorry. Here's my demand curve for labor, my supply curve for labor. Right? If I'm only allowed to give them this tuition remission, and it's somewhere down here, right? Then the equilibrium supply of labor is going to decrease. But even at that quantity, what is the value of that player to the university? Significantly higher than what it's going to cost that university to give them that tuition remission. If I'm saying you don't have to give me whatever it is, $12,000 for tuition if you're at in-state IU, that value is going to be significantly below kind of the marginal revenue per win times the marginal wins coming from labor from IU's basketball players or football players. I would go out on a limb, right, and guess that. So another point here is not only would they be paid far less than their worth to that school, right? So this is kind of, this is the injustice of it all, right? They're bringing in high amounts of revenue, even after you instituted this and they supply less labor, still generating much, much higher levels of revenue for the university, but they're being paid well below that, right? And, there's some industries where there may be some like monopsony power, but for the most part, wages, in the real kind of outside of sports, there's enough competition to where you kind of aren't paid whatever your worth is to that company, or at least within reason, right? You kind of hold everything constant. What's also interesting about this is, what's the actual cost to the university if they're giving this tuition remission? Very little, if not anything. It could be zero, right? So let's think about why. So there are some some traits that we need to have for that to be true. But more often than not, these tuition remissions cost the university absolutely nothing. The only way in which it would cost the university something is if that student wouldn't have otherwise attended that university, right? Because then if they don't give them the tuition remission, if the student would have still attended the university regardless, well, then they would have been making whatever in-state tuition was, $12,000, right? So by giving that tuition remission, it is costing them not getting that $12,000 from that student, right? So if that student athlete would have attended the university with or without the tuition remission, then it is going to cost the university whatever the value of that tuition remission is. However, if the student would have went there, if the student wouldn't have went there otherwise, then right, not giving the tuition remission, they're not foregoing anything because the student wouldn't have attended there. So in that case, the tuition remission costs them nothing. The only other scenario in which it would cost them something is if, and not a lot of universities, some universities are doing this, but if I have like a cap on enrollment, right? So I only accept, say, 10,000 students. Well, if I have a student athlete who wouldn't have went to my university otherwise, and I give them this tuition remission and they come play for my school, that's going to push out another just regular student who would have been paying tuition. So when giving that tuition remission, it is going to cost me in that scenario as well. And that might seem kind of wild. I don't think like Ball State necessarily has like a cap on enrollment, but a lot of universities, they get to a certain size, they will start to try to kind of, if they're generating enough revenue, they try to kind of even out what their acceptance numbers are. So that's not a wild assumption. We see that in practice quite a bit. All right, so where do I want to go? I think we'll go kind of do all this next class or next week. So I'm going to go off script a little bit here, but I think this is interesting. I was playing around with this morning. So, and I just more so want to show you kind of the power of what we can do with regression. I will not expect you to know how to deal with quadratic terms here, but I think it's at least worth kind of seeing an example and kind of seeing what this looks like with some real data. So I've got this regression, and I'm interested in whether or not somebody makes a free throw. So it's NCAA basketball data, and only every free throw that happened in the last 4 years, right? So if you're ever interested to, there's let me think if I can remember this off the top of my head. Big ball R and NCAA hoop R. If you've ever played around with R at all, are two packages that you can use to just scrape a bunch of data off of like the NCAA's website. It's got play-by-play data. It's got all kinds of stuff. So this is where that comes from. So we've got whether or not the free throw is made. Okay. What we're then going to think about is this variable which stands for win probability added, right? So what you can do is go through and look at what was the win probability based off of old games, right? Before the free throw was taken, and then after the free throw was made, what would the new win probability be? So you can imagine, like, if it's a 20-point game, well, the win probability, if there's a 20-point gap in the current score, that free throw, the win probability added is not going to be very high. But if it's a game in the last 30 seconds and it's tied, the win probability added of making one free throw really high, right? So this WPA variable should be some measure of like how much this shot matters. So what would we expect the sign of this variable to be? If this is measuring, right, the higher this gets, right, we're thinking about I'm adding a higher, increasing the probability of winning by more and more. So these are higher pressured kind of situations, or at least they matter more. What might you expect the sign of this coefficient to be? So if it was negative, right, I can think of two stories, right? The negative one is if it's really high pressure situation, that might cause some psychological distress, making it less likely that they make the free throw. However, if it's a free throw at the end of the game, it's 5 seconds left and I'm shooting it and it's a tie game, versus in the middle of the game, 25-point gap, I'm going to focus probably a lot more on what I'm doing in that free throw at the game. So you could have an increase in focus, right? So this sign, we really here could go either way. We've got kind of two effects that are kind of competing against each other. This is exactly what's going on. So let's run this regression. And WPA, like win probability, so that it's not a 0-1 variable, but it ranges from 0 to 1, right? So you think about, increases of probability winning by 0.1 or 10%, right? So these are kind of our units are going to be really, really small here, right? However, if I run this regression, and I'm doing this not in Excel, but it's worth kind of seeing some of these. So I've got what? 1 million different free throws here. And this WPA variable looks like it's positive, but if I'm looking at that standard error, I'm looking at my p-value, 0.877 is nowhere near going to be below any of my benchmark alphas. So this got me thinking, that's kind of odd. I'm surprised, like I know that there's competing effects, but like one of them should be stronger than the other, you think. So this kind of shows a problem with the fact that we are doing kind of like this simple linear regression, right? Now moving to multivariate, which is including more variables, helps kind of control for some of the other factors. So maybe that would change the sign. But I want to highlight something before we start adding in controls. Whenever I'm estimating a regression, so I've got my X and my Y variable. So I can think about here, my X variable is WPA. This is whether or not the free throw is made. Right? Essentially what I'm doing is saying, here's all this data. What's the line that best fits it? And then that coefficient is the slope of that line, okay? The problem is sometimes data looks like this, right? And I can't really get a line that really best fits this unless I allow it to have some curve to it. Okay? So how can I get a line that has some curve to it? Well, in general, we would include a squared term. Right? This is probably going back to like stuff you guys want to forget, but this is right. This is how we would kind of include a line of best fit that was not linear but had some curve to it. So in this case, right, there's an increasing relationship, right? As WPA gets higher, so is the probability I make the free throw, but it's doing so at an increasing rate. So we're going to look at, I don't know if that's going to be the case actually. So, but that would be that the drawing I had, that would be the situation. So let's now include this WPA squared variable, right? And look at the coefficient on that, okay? So now if I run this, I now get a positive effect, right? So shots that add a higher probability to winning are more likely for the player to make that free throw. So it must be that the attention or the increased focus is kind of winning out over the psychological pressure. However, I've got a negative sign on that squared variable. So it's actually looking something like this, right? So got my WPA, got that free throw being made. If it's increasing, but that second sign in the quadratic term is negative, it means it's increasing at a decreasing rate. So the actual relationship looks something like this. But notice when we tried to force it to be linear, we didn't pick up that there was any impact other than 0, right? So including quadratic terms, if that is in fact the true relationship between that X and Y variable, can go from looking like there was no impact of this thing, this WPA variable, this pressure or this importance of the shot in the game, when in fact there was a very strong relationship. These p-values are less than 0.01. So I can reject that there's no relationship at like the 99% level. And now it actually uncover, yes, there was a relationship, it just wasn't linear. So like I said, I won't make you kind of interpret quadratics or anything like that on homework or the exam or the final. But I do want to kind of show you like this is the power of regression. We can also pick up non-linear relationships. I'll keep everything linear though for us. Okay? And just kind of be complete. I don't know what this looks like either because I ran these and did not look at the results yet. So let's run this one. So this one I did like kitchen sink, right? So go up here. I've got all my controls. So I had like, what month, day of the week was it, right? Indicators for all those. I had, was it a tournament game? Was it the first or second half? The number of seconds left in the game, the score differential, et cetera, et cetera. All these different controls, what type of foul it was. I then went down and also included this thing where I controlled, or I included fixed effects for who the opponent was. So what team were they playing? Right? That should kind of help fix like the quality of the other team. And then I also included player fixed effects. Right? So this is really important because if I'm getting players, right, who are fouled in higher pressure situations, they're more likely, like, what's the opponent trying to do? Foul the worst player, right? And so I'm going to have like this selection into these really high, because these important free throws where I'm getting lower quality shooters, and then that they kind of screw up my relationship. But if I can control for what the player's kind of overall mean was in the year, then that, you know, I'm holding that constant now. So now I don't have to worry about the selection of the quality of player who's shooting the free throw. So these fixed effects essentially are going to do that, right? They're going to hold constant all the qualities that we don't have data on about that player. That would include their free throw mean that year, their height, their age, all these other things, right? So I shouldn't say age, because you could have been in the sample more than 1 year, but it would control anything that doesn't change over time about that player. So if we run this regression, this, you know, we've controlled for a lot of other factors, we may get some different results, right? So you can kind of see when you have a lot of observations, sometimes this takes a while. So I'm just filling space here until this gets done. But right, we're still going to be interested in that coefficient on my WPA, my WPA squared variable, because now we're going to have a whole bunch of additional controls. And I thought it would run faster than this. Well, maybe it's not going to run. It's still going. Let me think of something else. We're waiting for this. So, one thing you could also do in Excel, if you wanted to do these squared terms, right? You don't have to, but if you wanted to, essentially all you would do is create this additional column where you just took the original variable and you multiplied it by itself, or you just squared it. Now you've got a new variable, which is that squared, right? And then you would just include that as one of your X or your independent variables on the right-hand side. Well, maybe this isn't going to run before we're done here. Where did I put this? It should have ran earlier, so maybe I'll just pull up on the results. Data collection, WPA tables. I'll pull this open. So it looks like in this last one, yeah, so still negative, and then kind of the quadratic term was positive as well. So I was hoping that this would run, but I don't want to just kind of have us sit here and wait and stare at the screen. I'm going to put a blank piece of paper over here on your way out. I just want you to sign it so I can give you guys 10 for 10 for showing up today. Other than that, your homework is due by the end of the day today, so make sure you get that uploaded to Canvas, or if you have a hard copy and want to leave it here on the way out, feel free to do that as well. Okay? All right, I'll see you guys on Monday.